Chewy, what are you doing? Hello everybody, I'm Maths Physics and I'll be your host for today's The Maths Shell Physics Show. And today we will be talking about teleportation. To understand teleportation, we need to understand a phenomenon known as quantum entanglement, which is in its own way confusing, but when you simplify it down to two Lego figures, it becomes really quite easy. But before we use these, we're going to need to explain this on a whiteboard. Quantum entanglement is really something that's been developed over many years and has had many contributors. In fact, you'll probably hear about it in Marvel movies. And it basically consists of where two particles or more, usually photons or electrons, are linked together regardless of how far apart they are. And they don't physically need to move or travel to exchange information. This is the basis of teleportation, not physically moving something or physically sending it, instead sending information. And that's really important. And in fact, we've been thinking about so many uses of quantum entanglement rather than just teleportation. A network, a non-hackable network, which could be globally, it would be amazing. But I think quantum entanglement is really something that got me into physics, and I think you'll find this really interesting. And what you have to understand about quantum entanglement is, what you will learn as you go on about it is, it tells you things, not just about one, but about the other. If this goes up, I know that it's going to go down, which is really quite amazing, speaking that these can be millions of light years apart. And I mean millions of light years. Not just like one on the one side of the street and the other on the other side of the street. We're talking galaxies, solar systems. I think it's one of the most interesting things you'll learn about in physics, personally. If you've ever watched Marvel, you know that these two have a connection. You've got Dead Strange and you've got Doctor Strange. And they're both from two different multiverses, but if we look at them in a more physical point of view, they do have a connection and a relation. Let's imagine that Doctor Strange is on this side of the room and that Dead Strange is on this side of the room. That's basically a bit like how two photons would work if they were quantum entangled, where Doctor Strange flies up here, goes up, and instantly I'm going to know that Dead Strange is going down.
So, are there any interesting facts about entanglement?
No, I kind of feel like you knew that you were going to ask that question at the start of the video, but there is actually. And it's the sort of thing that you're going to get many amazing facts out of. But one that I learned from Michio Kaku's book, Physics of the Impossible, which, in my opinion, is one of the greatest physics books I've ever read. And it has many sci-fi and other aspects towards it. And I found it really enjoyable. But what you learn from his book is that, imagine the beginning of time, the Big Bang. Our bodily electrons were created, right? And we're made of atoms, and atoms have electrons, electron shells, so on, etc. Some of those electrons may have been entangled with other electrons. And this is the bit where I was reading in the school library, and I read this, and I went to my friend, and I was just, this is amazing. This will blow your mind. But they got entangled with another electron. Just imagine that's a body. Obviously, you know that the electron's going to be way, way smaller than that. Because if you're imagining the size of an atom on a pinhead, well, a pinhead has trillions of atoms, so I think that says a lot about how small an atom on your body is going to, well, an electron on your body is going to be. But if you just imagine it in a diagram, if you imagine it like this, if something happens to that electron on your body, it will affect the electron all the way across the galaxy, or across the solar system, or at the very end of the universe that is entangled with that electron. And since they're entangled, something will happen to that electron just because it happened down here.
You mentioned that this video is about teleportation. So how can this complex structure be applied to teleportation?
Good question. Now, what's important to understand is teleportation in sci-fi films such as Star Trek, of transferring human atoms to another place. Yeah, in general, it looks most likely that's in the next century or so that's not going to be happening, or even it may not even be possible, but I'm not going to just rule that out. But what we have to understand is humans have trillions of atoms. Trillions. Like, trillions is not even the right word for it, because there are way, way more atoms than just trillions. So, in a teleportation aspect of it, we have to imagine it as more of a teleportating complex molecules or particles. For now, hopefully. Maybe one day we might be able to do an object, or something that we can at least see with that human eye. But for now, I would say it's looking more like just very small, microscopic things. But quantum teleportation involves transferring the quantum state of a particle from one location to another using entanglement. So entanglement, which is why we have to understand entanglement, because we need entanglement to move that quantum state, that information. And that's basically that. But the physics of teleportation is perfectly reasonable, which is why it's so fascinating. And what we've learned from researching into this is just, it's mind-blowing. And it teaches you that thousands of years ago, when we didn't know about any of this stuff, this was all still going on. And how much humans have developed and understood about the particles that make up this universe.
So after that explanation, it's clear that teleportation can't be achieved, right?
Now, as a body, as a human, yes. For now, hopefully. But now this is pretty exciting. Teleportation has been achieved. This was a few years ago. From the ground, Chinese scientists sent a beam of light, and whether it was multiple photons or just one photon, I actually can't say, but through the MIT Technology Review states that from the ground they sent a beam of light up to the satellite Micius, named after a Chinese philosopher, and this was through quantum entanglement. And that's really impressive, actually, and this is a huge feat in human history. Well, that's all from me. I hope you enjoyed this video, and have a nice day.